Alright, so I'm going to go over the word problems, which were 17, 18, and 19. I didn't feel the need to go over 16 because all you are doing is finding the maximum. So hopefully you've had enough practice with that shouldn't be too bad. Alright, so 17 actually gives you the picture, which is really nice. You don't have to create it on your own. If you think about a fence, how much do you need? You can think of that in perimeter to maximize the area. We have to remember that area is equal to length times width. So in this case, we think about that as 850 minus 2x times x. Remember, you only do length times width, so you don't need to multiply by the other x. So if I distribute, I get 850x minus 2x squared. Remember that this is A and this is B. So the first part of the question asks the width. So all we're going to do is find the maximum here. So if you find a maximum on your calculator, I would never know the difference, so whatever. Or you can do negative b over 2a, which would be negative 850 over 2 times negative 2. And just to make sure my calculations are right, because I know the right answer, but I haven't, I get 212.5. And so that is x. X is 212.5. My next part says, what is the length of it? So remember, my length is 850 minus 2x. So I am going to substitute in 212.5 into the equation, and my output would be 425. This is where you pause and type that in your calculator and verify that that's what you get. So part 1, part 2. And the last part says the largest area that can be enclosed is blank square meters. So you're going to take the parabola function there. So what you did essentially was find the vertex, right? You found the x value of the vertex, and that was x. The y value of that vertex is the max area. Okay, so to find, if I know the x value, to find the y value, everywhere there's an x, I just sub in that x value. And I should get 90,312.5. So I did all these calculations ahead of time, so I know the answers. So that's how I did that fast. So there's part 1, part 2, this is part 3, and you have successfully finished 17. Scrolling right along. A rectangular playground is fenced off and divided into 2 by another fence parallel to one side of the playground. Okay, it may or may not be divided directly in half, but that's okay. 780 feet of fencing is used. Find the dimensions of the playground. Okay. So when I'm thinking about how much fencing I have, I want to think about perimeter, because the fencing is the perimeter here. One of the lengths is, I'm going to call x. So if you think about that, to be a rectangle, those 3 pieces have to be the same length, right? So I'm just calling them all x. And then the length of the entire rectangle we'll call y. Okay. So in this example, that means that my perimeter is going to equal 3x plus 2y. And I know that my perimeter is 780 feet. Okay. I also know that area is going to equal x times y. Recall your Algebra 1 skills of isolating a variable so that you can then substitute it back in. So here's what I mean. If I were to get y by itself here, I could have 780 minus 3x equals 2y. Then I divide that by 2 to get y by itself. Well, why would I ever do that? Well, because then I can sub it in here for y, because remember x and y are the same for both equations. And now I only have one variable there. I will have $390x minus 1.5x squared. Okay, and so then we want to find the x value that maximizes that area. So that means where is the vertex for that parabola? Okay, and I would do negative b, so negative 390 over 2a. If you are not getting a right answer when you put this in your calculator, my guess is that you're not putting parentheses around the bottom. So make sure that you are thinking of that separately because that is important. Okay. And then, so, sorry, I'm typing it in here. I should get 130. So 130 is the smaller width, right? Now, how would I find y? Well, I could substitute it back in to this equation. So, well, this equation, I guess. I would have 780 equals 3 times 130 plus 2 times y. So I get 390 which is actually half of it. So that means 390 equals 2y. So what is half of 390? 195 would be y to maximize the area. And then what would that area be? What happens when I plug in 130 to my parabola? So 390 times 130 minus 1.5 times 130 squared. And that equals 25,354 part 3. Right? By the way, quadratics are more real world applicable than a lot of the other things that are taught at a high level math course like this. The good part now is that computers can generate a lot of these for us and do all the work for us. So just like I'm talking about the vertex here, I could absolutely graph that. A lot of your coding is automatically doing this stuff for you. So someone has had to write that computer code. So just know that that is a thing. The same goes for this next one, cost and revenue. Like this is true types of variables. Now, we're not really getting into how did they create the R of X function in part B, but it can be created with data that you have, and therefore you can find these types of answers. So this is not just completely made up types of things. So we have a local sandwich store. This is number 19, by the way, of your 3.1 homework. Let X represent the number of roast. Oh, sorry. Let's go up a little bit. A local sandwich store has a fixed cost of $555, and a variable cost for making a roast beef sandwich is 55 cents for every roast beef sandwich. If we let X represent the number of roast beef sandwiches made and sold each week, write the weekly cost function C for the local sandwich store. It even gives you a hint that it's just the sum of the fixed variable or the fixed and variable costs. So we know we have to spend $555 every week. Plus we have to spend 55 cents for every roast beef sandwich that we make. Okay. So then we want to use that knowledge, and the function R of X equals negative 1,000th X squared plus 3X describes the money that the local sandwich store takes in each week from the sale of X roast beef sandwiches. So if they made 100, it would tell you how much money they brought in. Use this revenue function and the cost function to write the profit function. So think about it. If you have all this money coming in, that's your revenue for a business, and then you know that your cost, so your bills to pay before you get to take home any of that money, in order to find your profit or to find what you're bringing home, you're going to do your revenue minus your cost, right? So, you brought in $1,000, but you have to pay $500 off, then you're only bringing home, your profit is $500. So we're going to do the same thing here. So negative 0.01 x squared plus 3x minus the cost. Remember, parentheses are important here because you got to be able to distribute that negative sign. Some of you guys missed that whenever I was grading the test, so don't do that. All right, so I'm left with negative 0.0, oops, I forgot a 0 there. 0.1 x squared plus 2.45x minus 555. That is my profit statement. I got 2.45 by doing 3 minus 0.55. And for those of you working on your mental math skills, I find it always easiest to think of it as money. If I had $3 and I spent 55 cents, how much money do I have? For some reason, that registers much easier to me. Like I actually picture 55 cents going away. How much am I left with to get the 245? So just a little mental math quick tip. All right, so now we're going to use that profit to determine the number of roast beef sandwiches it should make and sell each week to maximize profit. So here's the idea. If I make too many roast beefs, my profit, the 55 cents, is going to get to me. If I don't make enough, then that $555 is going to get to me. So I want to maximize my profit. Like, where do I want to stand here with the bills that I have to pay? Well, that's just the maximum of that quadratic function. Okay, so that's negative b over 2a. Lucky for me, I've already done this math, and it's $945.63. So make sure to round like money. So how many sandwiches do I need sold then? Okay, that's my y value. So back to my original function. So everywhere there was an x, I plugged in 945.63 and then typed all that in my calculator to get 1,225 sandwiches sold. You can always check your work by graphing. So I actually have that one here. I have that backwards. Good job. Go me. That's what I was afraid of. Part of the reason I wanted to check it. So I didn't actually do my math. These two are switched. So I actually get the sandwiches first, which makes sense had I thought this through, because I was looking at the answers. If I had thought this through, remember X stood for sandwiches up here, and it never lost what its meaning throughout there. So 1,225 sandwiches are sold. I plug that in everywhere. And that equals $945.63 if I round. So that is corrected. Sorry about that. I had a hunch that was wrong, and that was correct. All right, so hopefully these help you with your word problems.